Hello everyone, today I will be teaching you about electrolysis. First, what is electrolysis? Electrolysis is the process of converting electrical energy back into chemical energy. Now let's say we have this beaker here, and we make our anode, and we also make our cathode. So in this example, we'll also have an electrolyte, and this cathode will be zinc, okay? And we'll have this electrolyte, like the battery fluid, that will become copper sulfate, okay? Copper sulfate. Now, when we run an electrical current through this, let's just label it. See, as you can see in this example, the anode and cathode have switched charges, so the anode is now positively charged, while the cathode becomes negatively charged. So let's say that we have a battery connected to this system, and we also have our voltmeter right here. When this happens, both our zinc and copper will react in what we call a displacement reaction. Our final product for this reaction will become zinc sulfate. Okay, now let's just write the full reaction real quick. Oops. So basically, our full reaction will become zinc plus copper sulfate and that will turn into zinc sulfate plus copper. But you have to keep in mind that there will be different reactions. So the reaction at anode will turn zinc into an ion, and zinc will be reconverted back when it reacts with the sulfate. Okay? So now let's show our full reaction. So we have zinc, which reacts with copper sulfate to give rise to zinc sulfate plus copper. Now keep in mind that here the copper will become an ion because it has been displaced from its copper sulfate form, but it will recombine with its 2 electrons that it's lost to form copper again. Okay, so that's basically how electrolysis works. We've used this electrical energy to rebind some chemicals back into a form that can release chemical energy again. Okay, so that's our overall reaction. As you can see here, 2 electrons are produced. Okay, but usually these 2 electrons cancel out with the copper to just form regular copper. I've just written it like this here for easier understanding. Okay, so this 2 electrons usually doesn't happen in a reaction, and it'll just be cancelled out by other factors. So just keep that in mind if you're ever trying to balance electrolysis reactions in the future. Okay, let me just clear the board quickly. So now I Now I'll be demonstrating a reaction of electrolysis that involves using lithium and carbon, as well as some cobalt. So here our electrolyte will be lithium carbide. Our anode will be cobalt oxide. No, sorry, our anode will be graphite. And our cathode will be cobalt oxide. Okay? As you can see, again, our anode is positively charged and our cathode is negatively charged because this is an electrolytic cell instead of an electrochemical cell. So this is our graphite. So this is our anode, graphite. Now, for our cathode, we will have cobalt oxide, which is also known in its chemical form as COO2. And our electrolyte, as I mentioned before, will be lithium carbide, and in its chemical form, it's LiC6. Okay, so in this example, we have two reactions that will take place, one at the anode, one at the cathode, and there will be a final overall reaction where we show all of the products. Okay, so basically that'll be the same for every electrochemical and electrolytic cell, since usually the anodes and cathodes are different, but in some cases there can be just one reaction written, like the one I showed you before where we had the same anode and the same cathode. Okay, now let's start with our reaction at the anode. It's denoted by that little A over there. So our lithium carbide electrolyte turns into just carbide and lithium. Now the reason that we don't see any excess carbon from the graphite here is because graphite is a neutral anode, or we can say a neutral electrode, where it doesn't have any involvement in the reaction. Okay, so this produces a lithium ion with one electron. Now in the cathode, we have our cobalt oxide. Okay, and that will react with our lithium ion from the previous reaction and the electron to turn into this is going to be our final product, because in this example the ions are getting transferred from the anode to the cathode, like how it always happens. So we will finally get lithium cobalt oxide plus carbide. Okay, so we can write out our final reaction as lithium carbide plus copper oxide, cobalt oxide, which will give rise to lithium cobalt oxide plus carbide. And that is all of our reactions for this specific electrolytic cell. So as you can see here again, that electrical energy it isn't shown on the diagram, but there will usually be a wire connected, okay? And that electrical charge has allowed us to form these compounds which can release electrochemical energy. Now let's just clear the board quickly. Let's say we have another beaker and we have some electrolyte as always. Okay, so in this example I'll be showing you an example of electroplating. Let's say we have our cathode and our anode. So here our anode is copper, and for this anode the electrolyte is copper sulfate. Sorry, the cathode will become will have a copper sulfate electrolyte, and the anode will be copper. It isn't copper sulfate. You can see I wrote this because the main reactant here will be copper sulfate. And for the second one, the anode, the electrolyte is water. So as you can see here, we have two different electrolytes that are being used. So let's say we put some metal in this beaker. Okay? We are trying to put the copper on the metal through a process known as electroplating. Okay? So at the cathode, what will happen is copper, just to clear it up, copper sulfate is the electrode. And because there are two different electrodes, we have sort of tubes around each electrode. So we have two different electrolytes, not two different electrodes. So one is water and one is copper sulfate. So in the second one, it's not copper sulfate. I understand that this diagram might be a little confusing. It's just indicating that the hydrogen will react with copper sulfate, but the anode is copper, and the electrolyte for the anode is water. Okay, so at the anode, a copper ion converts into just regular copper through the use of an electric current, because that electric current has displaced two electrons in the copper, so it has to regain them back. Now at the anode, the reactions are particularly interesting because here again we have a sort of neutral electrode. So our water electrolyte splits into 4 hydrogen ions plus oxygen gas and obviously 4 electrons. But the first reaction to get to this state, there are 2 reactions that take place at the anode that sort of form a repeating loop until all the water is drained out. So we will have 4 hydroxide ions, okay? And hydroxide has a charge of -1, so we'll just write that, which converts into our water. Our oxygen gas and our 4 electrons. Okay? So now here we will be using our hydrogen to get rid of the copper, because hydrogen is more reactive than copper. Okay? So that'll displace the copper and the copper sulfate to form sulfuric acid. Now, I've just drawn that arrow there to indicate that this reaction can give rise to that other reaction. Okay, so here in this example, our 4H plus ions, which were released by our water, will react. There's actually just a slight error here. What will actually happen is our 2 hydrogen from the water will react with the copper sulfate to form sulfuric acid and copper. Just ignore the 4H plus for now. The 4H plus actually gets transferred into the hydroxide ions. But the final product will still remain the same, where we will have 2 sulfuric acid and 2 copper as our final product. And this 2 copper, it'll fall onto the metal and sort of attach itself onto the metal surface. Remember the metal we had like from before, and this will form our electroplating. Okay, where this copper from our electrolysis reaction has fallen onto the metal to sort of cover it and protect it. Anyways, that's all for this video, and that was all the final reactions. If you have any questions, please ask in the comment section below. Thank you, and bye.